So this is going to be the review for the quiz that we took on Friday that we're going to take tomorrow on Monday. So we've got the volume of sodium hydroxide solution as being 20 milliliters. This is the 1 molar solution. And what we're saying in that next box is that we're adding 180 milliliters, meaning that we're diluting that amount. And this dilution is actually going into this one. So in order to figure out the molarity of the dilution, what we're saying is we started with 0.02 liters, that is 1 molar. We added a total of 0.18 liters of water, which gives you nothing in terms of the concentration. If we pour all of that and all of that into a jar of its own, we end up having 0.2 liters, and we're trying to figure out what the molarity of this is equal to. So if we can figure out the number of moles in that first solution over here, we can figure out the number for the molarity in the third solution. So when we have 1 molarity, what we're really saying is a molarity for every statement. For every 1 mole, there are 1 liter. We don't have 1 liter, but rather 0.02 liters. So times 0.02 times 0.02. So what we have is 0.02 moles. There are 0.02 liters. So there is 0.02 moles in here. That's exactly how many moles there are in here. So let's actually go ahead and figure out what the molarity then is going to be based off of those two numbers. So in that jar, that third jar, we have for every 0.02 moles, there are 0.2 liters, and we're trying to get to a for every statement that tells us the molarity, which is the molarity for every statement, which ends in 1 liter. So we're multiplying by 5, and we're multiplying by 5, and what we should get is 0.1 moles for 1 liter. And this right here, because it's ending in 1 liter, that is the molarity. So the molarity for this is 0.1. So that's what I was asking for in that first part. For the next box, the moles of sodium hydroxide, what we're really saying is using the answer that we got in the previous one and the amount of sodium hydroxide that we're using on average. What is the amount of moles of sodium hydroxide that we're ending up with on average? So using the for every statements again, for every 0.1 mole, there are 1 liter. This is using this number over here, and that's our molarity for every statement. We have to figure out how many moles of sodium hydroxide used in this much liters worth. So this is 0.017, so we're multiplying by 0.017. If you do the same thing there, what we should get is 0.0017 moles, 0.0017 as the number of moles of sodium hydroxide, and we got that using the previous two boxes. For the next part, the moles of ascorbic acid, that's the vitamin C. Even though I gave you these numbers over here, what you'll find is it's a little bit more than 0.3, but I told you in the earlier part with the paragraphs that we're working with 300 milligrams worth of vitamin C, so we know the amount of grams there. And we know the formula weight, so let's go ahead and write out our for every statement for that. So for every 176 grams of vitamin C, there are 1 mole. And we're trying to figure out how many moles there are based off the fact that we used 0.3 grams. And what we should get when the conversion factor, 0.0017 as the number of moles. And what you notice is that the number of moles of the ascorbic acid is equal to the number of the moles of the NaOH. And this makes sense because it's a 1-to-1 ratio in the actual equation. Then the last box, the molarity of the ascorbic acid, what I wanted was to use that number you got there and that number to figure out the molarity of this scenario. So let's write out a for every statement of that scenario. For every 0.0017 moles, there are 0.04 liters, and we're trying to get to a molarity for every statement, which ends in 1 liter. So 1 liter, we figure out the conversion factor, and we should end up getting a molarity of 0.042. So So this should have been 0.042 molarity. Then the last problem asks you to find the pH of ascorbic acid that you ended up using. So we wouldn't use the equation that's at the top of this page because it doesn't really tell us the H3O plus concentration, but we would use this number from our table. So if we were to actually write the ascorbic acid, it's HC6H7O6, and it would be with water because we're trying to figure out the H3O plus concentration. We would end up with H3O plus and the C6 ... whatever that is. So this molarity would actually be the molarity of the ascorbic acid. These would be 0 and 0. The change would be minus x, and here it would be plus x and plus x. And because this is a weak acid, we're going to assume that this minus x isn't going to make much of a difference on this number right there. And what we would end up with is 0.042 x and x, and we would have x squared divided by 0.042 is equal to 7.9 times 10 to the power of -5. When we solve for x, we're actually solving for H3O plus concentration. So what we're saying is the H3O plus concentration is equal to 0.00183, but the question asks for the pH, which would be the negative log of this number, and what we would end up with as the pH equals to 2.74. And that's what I basically wanted.